Hey, welcome to Build&AI. I'm Nia, your AI learning guide. Let's get into it.
Hey everyone, welcome to the Explainer. I'm so glad you're joining me today because, well, we're doing something super practical. We are jumping straight into our ultimate exam bootcamp, unpacking a pretty dense study guide covering software architectures and databases. If you've been staring at your notes trying to synthesize how all these backend systems and structures actually fit together, you are in the exact right place. We're going to make this efficient, structured, and exceptionally easy to retain. Here is our game plan for today. We've got 1. Basic software architectures. 2. The client-server model. 3. Relational databases. 4. The non-relational world. 5. Graphs and connections. And finally, 6. A key exam review. All right, let's kick things off with Section 1. Basic software architectures, building the foundation. So let's dive into this first major comparison. On one hand, you've got monolithic architecture. Think of it as this single massive deployable unit. It's highly coupled, which basically means all its parts are deeply tangled together. The downside? One tiny bug in a single module can literally crash your entire system. Yikes. Now, contrast that with microservices architecture. Here, the app is broken down into small, independent services. They just chat with each other through APIs, kind of like digital messengers. It's highly scalable and, thankfully, fault-tolerant. And you know what's really interesting? Looking at who actually relies on microservices in the real world. We're talking tech giants here. Netflix, Amazon, Google. Fun fact for you, it took Netflix around 7 agonizing years to migrate from a monolith to microservices. So why go through all that pain? It all comes down to achieving massive scalability and, frankly, managing incredibly large development teams without everyone constantly stepping on each other's toes. Okay. Moving on to another vital foundation, layered architecture. Think of it kind of like a restaurant. The presentation layer, that's the dining room where you look at the menu, your user interface. Then there's the business logic layer. That's the kitchen cooking up the food, representing the core system rules. Finally, the data layer is the pantry storing all the ingredients, which is your database. Because of the strict separation, if you decide to repaint the dining room, you don't have to rewire the kitchen appliances. Makes sense, right? Moving right along to Section 2, the client-server model, the backbone of the web. So how exactly do these two actors interact? Well, the client takes on the active role. Think of your web browser. It's user-facing and initiates the communication. The server, on the other hand, sits passively. It acts like a secure vault, processing data, centralizing control, and waiting to send a response. And to talk to each other, they use standard protocols, essentially a shared digital language, like HTTP, FTP, or SMTP. Now, this dynamic builds into a couple of different structural models. First, we have the standard 2-tier model, where the client talks directly to a single server that handles both the logic and the data. Pretty straightforward. But look at the 3-tier or N-tier model. This adds a dedicated application server right smack in the middle. By putting this sort of bouncer between the application logic and the database storage, you get significantly better security and incredible flexibility. Next up, Section 3, Relational Databases, the strict organizers. When we talk about relational, or SQL databases, we are talking about strict, rigid rules. Data is stored very neatly in tables, using rows and columns. You absolutely must have a fixed schema, a strict architectural blueprint defined before you ever insert a single piece of data. They use primary and foreign keys to enforce strict relationships, and of course they use structured query language, or SQL. Now, all this rigidity, it actually makes SQL absolutely perfect for things like banking systems, where you demand flawless, strong consistency. All right, on to Section 4, the non-relational world, flexible storage. This example right here brilliantly illustrates what we mean by flexible. In a NoSQL database like MongoDB, data isn't just jammed into rigid tables. Instead, it's grouped into collections of flexible documents. What you're seeing is a JSON document, which stands for JavaScript Object Notation. Check out the syntax. You've got text keys and string values all wrapped up nicely in double quotes. And here's the kicker. Because there's no fixed schema, the very next document in this exact same collection could have completely different fields. But hey, there is a super critical behind-the-scenes detail you need to know. While we humans read and write in that standard human-readable JSON text, MongoDB internally translates all that data into BSON, or binary JSON. Why? Well, it's just highly efficient for the machine to read. And crucially, it supports extra data types that standard JSON just can't handle, like specialized date formats and unique object IDs. Let's pivot to Section 5, Graphs and Connections, the networking experts. Graph databases are a totally different beast. They model data as nodes, which are the entities, and edges, which are the relationships connecting them. In a standard relational database, linking heavily related data requires joins, and joins are this costly, slow process of mathematically matching rows across different tables. Graph databases, they completely bypass that heavy lifting by using literal direct connections. For example, using an engine like Neo4j and its cipher language, this setup is absolutely perfect for building complex social networks or recommendation engines. Okay, let's consolidate all of this into the ultimate study cheat sheet. First, SQL. Organized in tables, uses a fixed schema, and it's built for strict consistency. Then, NoSQL. Built on documents, incredibly flexible, and designed to scale horizontally, meaning, you just add more cheap servers rather than buying one massive supercomputer. And finally, graph databases. Purely nodes and connections for incredibly fast network queries. Seriously, take a mental snapshot of this matrix right now. It's a game changer for the exam. And finally, Section 6, Key Exam Review, the Pop Quiz. All right, time for a rapid-fire pop quiz. Here's your first active recall question. What is the main difference between monolithic and microservices architectures? I'll give you just a second to mentally lock in your answer. Got it? The answer is coupling versus independence of services. Remember, a monolith is tightly coupled and rigid, while microservices are independent, autonomous, and scalable. Awesome. Let's fire off the next question to test your attention on those NoSQL specifics. What uniquely identifies a document in MongoDB? Think back to our discussion on BSON a minute ago. All right, time's up. It's the _ID field, which contains an object ID. That BSON-specific identifier is automatically assigned behind the scenes to make sure every single document stays completely unique. Okay, one final review question on structural organization. What exactly does layered architecture separate? Think about that restaurant analogy we used. Take a second. And the answer is presentation, business logic, and data. By keeping the user interface, the core system rules, and the database storage strictly isolated from one another, you make maintaining the whole application way, way easier. Well, you've absolutely nailed this review, but to wrap up our bootcamp today, I want to leave you with a challenge. Knowing all these trade-offs, which architecture will you choose for your next real-world project? Are you going to prioritize the strict consistency of SQL, the flexibility of NoSQL, or maybe the massive scalability of microservices? Stepping out of test-taker mode and actually applying these blueprints to real problems, that's what makes a true software engineer. Keep studying smart, and I'll catch you on the next explainer.
And that's a wrap for today. If this lesson was helpful, go ahead and hit that subscribe button so you never miss a new episode. We drop 3 new lessons every single week, all designed to help you learn, build, and launch with AI. Share this with someone who's on the same journey, and I will see you in the next one.